change, use the standard enthalpies of formation in table 5.3 to calculate the standard enthalpy of formation of copper oxide. Okay, so we have copper oxide as a solid plus hydrogen gas goes to copper as a solid plus water as a liquid.
What page in practice exercise was this again?
This was page 194, practice exercise 2 at the bottom of the page. Okay? 194, practice exercise 2 at the bottom of the page. All right, so we don't know this one. They're saying that one's not going to be on our table. We've got to figure that out. Okay? We know that hydrogen is 0, copper is 0, water is 285.83 kilojoules per mole. We've used that one a couple of times, right? Negative, put the negative in there. We also know that delta H for the reaction, they told us, was a negative 129.7 kilojoules. So we have delta H for the reaction is equal to a negative 129.7 kilojoules per mole. Okay? Yeah, get it copied right. Therefore, that is going to be equal to the products, negative 285.83 kilojoules, not worrying about the 0, minus the reactants, that's the X that I don't know, right? So now I can solve for X. X is going to be a negative 285.83 kilojoules plus 129.7 kilojoules, right? Again, these really are kilojoules per mole. I'm just getting lazy about writing it. Okay? My algebra good? I get that to be a negative 156.1 kilojoules for the delta H formation of copper oxide. Okay? Any questions on how we did that? Yes?
Now the bottom step, you're just taking the sum.
I'm rearranging this equation to solve for X, right? X was negative, so I actually added X over here, and then I subtracted it, well, added that over there because this was negative, right? So it had to be added over, okay? So I was just solving for X. So the same type of principle as what we've been doing with these other ones, it's just rather than having all the delta H's of formation and solving for the reaction, this time we had the reaction and we were missing one of the delta H's of formation, so we solved for it. Okay? Any questions? In a lot of ways, these are actually easier than Hess's law, aren't they? Because you don't have to rearrange things and flip things backwards and all of that kind of stuff. You just look up the values, okay? All right, that finishes chapter 5. There is a section at the end of chapter 5 that talks about fuels and food and different things like that. I believe that there is 1 or 2 questions on mastering chemistry that ask about it, but they are very general. You can just look through the pages to get it, okay? We're not going to take class time to go over that, and I will not test on the fuels and food, all right? So we won't have quizzes, we won't have tests on fuels and food, just the other parts of chapter 5. There's plenty to worry about from chapter 5, right? We had stoichiometry with delta H's, then we had specific heat capacities, and we used the specific heat capacities for calorimetry, right? Then we did Hess's law, and then delta H's of formation, okay? okay? So lots of math type of stuff. It's fairly straightforward algebra, but it's math that's easy to make bookkeeping errors, so be really careful as you do them. Okay?